Welcome to The Explainer. Let's get right into it, because today we're looking under the hood of the tallest structure ever built by humanity, the Burj Khalifa. We aren't just going to look at the architecture here. We're really going to deconstruct the extreme engineering and the massive economic engine that actually makes a half-mile-high skyscraper possible.
So we all know it towers over Dubai at a staggering 828 meters. But the real fascination is in its survival. How does a building of this unprecedented scale survive the brutal, unforgiving forces of nature half a mile up in the air? And honestly, perhaps more surprisingly, how does a megaproject with such astronomical construction costs actually function as a calculated, wealth-generating financial engine? Well, that is exactly the paradox we're going to unravel today. Here is our roadmap. We'll start with engineering the world's tallest, then we'll look at illuminating an extreme environment, explore the economic halo effect, and finally peek into the future with the next megatall giants. Okay, let's dive right into Section 1, Engineering the World's Tallest. Think about this for a second. If you try to build a standard square skyscraper half a mile into the sky, it would bend, it would twist, and ultimately it would snap right under its own massive weight and intense wind pressure. The traditional grid systems we use for normal office buildings, they literally just stop working at that altitude. The Burj Khalifa only survives because of a radically different internal skeleton called a buttressed core. Picture a central hexagonal hub supported by three massive connecting wings. This triaxial Y shape provides extreme lateral and torsional stiffness. It essentially acts like the closed tube of a heavy-duty mechanical axle, locking the entire massive structure rigidly into place, so it absolutely cannot twist. Now, this Y-shape isn't just an engineering cheat code for structural integrity, it is an absolute masterclass in real estate optimization. I mean, when you're building luxury residences and high-end hotels, nobody wants to be stuck in a dark interior room, right? The branching Y-shape maximizes the outward views and inward natural light for the maximum number of units. It's incredibly ideal for the premium spaces packed inside, basically ensuring that nearly every single room feels like a corner office with a panoramic view of the skyline. Of course, all of that soaring concrete and steel up in the sky needs a massive, invisible anchor holding it down. We're talking about a foundation consisting of a 3.7-meter-thick concrete raft resting on 194 massive board piles driven 43 meters deep into the earth. But here's the really crazy part. The groundwater under Dubai is incredibly hostile. It is absolutely packed with highly corrosive chlorides and sulfates that act almost like battery acid to a normal steel-reinforced foundation. Left alone, over a few decades, it would literally eat away the base of the building. To survive this underground chemical attack, engineers implemented specialized cathodic protection. They basically run a continuous, highly calculated electrical current through a titanium mesh buried right in the foundation. This forces the corrosive elements to attack the sacrificial mesh instead, which perfectly preserves the building's vital concrete and steel anchor forever. Okay, so the ground is conquered, but as we shift our focus from the earth up to the sky, we run into the single biggest threats to any super tall structure. When you're building 828 meters high, how do you stop the wind from just knocking it right over? Well, as wind whips around a tall, flat building, it creates alternating whirlpools of air called vortices. And if these vortices organize, they can violently shake a building apart, a terrifying phenomenon known as vortex shedding. Think of a flag violently snapping back and forth in a strong breeze. That snapping, that's vortex shedding in action. If an 828-meter building snaps like a flag, yeah, that's a structural catastrophe. The Burj Khalifa actually solves this by constantly changing its width at each setback as it rises. This spiral stepping pattern literally confuses the wind. Because the building's shape is always changing, the wind never gets the chance to organize. It's broken up before it can forcefully push against the tower, which keeps the entire structure and everybody inside it perfectly still.
Let's move on to Section 2, Illuminating an Extreme Environment.
70,000. That is the staggering number of individually addressable LED nodes installed across the facade. Back in 2018, the tower underwent this massive visual upgrade, completely replacing its original white-only lighting system with these multicolor RGBW pixels. And this wasn't just, a simple light bulb swap. They essentially transformed an 828-meter building into the world's tallest, most complex media display. It's capable of wrapping the entire structure in fluid, choreographed animations that are visible from over 10 kilometers away, right across the Dubai desert.
But keeping 70,000 lights functioning half a mile up in the sky requires running an absolute technological gauntlet. The environment up there is incredibly hostile. Sustained winds routinely exceed 80 kilometers per hour, which requires highly specialized vibration-rated connectors so the lights don't simply shake themselves loose and fall. Then the desert creates brutal daily temperature swings of 15 to 20 degrees Celsius. That constant thermal expansion and contraction forces engineers to use fatigue-resistant alloys for the solder joints so the electrical connections don't crack. On top of that, UV intensity is heavily magnified at that altitude, demanding stabilized optics that won't just cloud over time. And perhaps most intensely of all, the spire takes up to 8 direct lightning strikes a year. Because of this, the entire display system requires massive 10 kiloamp surge protection just to survive the seasonal storms. All of that just to keep the lights on. All right, shifting gears a bit, Section 3, the economic halo effect. 30 to 40%. That is the astonishing premium buyers will willingly pay for a residential unit simply because its window frames the Burj Khalifa. Think about that for a second. The mere physical presence of this tower artificially inflates the value of everything around it. Residential towers in the immediate downtown area see some of the absolute highest price per square foot rates in the entire city. We're talking hotel-branded residences situated near the tower regularly exceeding $1,500 per square foot. The building doesn't just stand there looking pretty as a piece of art. It physically radiates wealth, generating massive financial returns for all the real estate surrounding it. And those indirect impacts? They ripple outward across the entire local economy. The tower basically acts as the ultimate anchor tenant for the entire city of Dubai. Because it's there, local hotels can command the highest occupancy and nightly rates in the region. It guarantees this relentless river of tourist footfall for nearby retail spaces, which directly contributes to making the adjacent Dubai Mall one of the highest-grossing retail destinations on Earth. On a macro level, the building secures endless free international media exposure for the city. It constantly accelerates foreign direct investment, acting as a permanent 828-meter billboard that signals Dubai's global ambition and economic stability to investors all over the world. Which brings us to our final topic, Section 4, the next megatall giants. So the Burj Khalifa has held the crown for the world's tallest building since 2010 at 828 meters. But a fierce race is currently brewing over in the Middle East. Saudi Arabia's Jeddah Tower, which is actively under construction right now, is aiming to officially break the kilometer mark at 1,008 meters. But the true paradigm shift is the proposed Rise Tower in Riyadh. Currently in its aggressive design phase, this structure is aiming to hit a mind-blowing 2 kilometers into the sky. That is more than doubling the height of the Burj Khalifa, pushing architecture into a realm that honestly almost sounds like science fiction. But you can't just take the blueprints for the Burj Khalifa, scale them up by 200%, and call it a day. Building a 2-kilometer tower demands an entirely new era of engineering. We're talking about absolutely unprecedented advancements in multi-stage elevator systems. Think about it. If an elevator goes too fast over 2 kilometers, the air pressure change would painfully pop the eardrums of everyone inside. It demands completely new ultralight material composites to handle the sheer vertical weight, because standard concrete is simply way too heavy at that scale. And it requires taming atmospheric wind currents that behave very, very differently at 2,000 meters in the air compared to down at ground level. And that brings us to the ultimate question. With these new towers meticulously planning to double the height of the Burj Khalifa over the next decade, is there a physical limit to how high human ambition and engineering can actually reach? Or are we really just getting started? It's definitely something to ponder the next time you're looking up at your own city's skyline. Thanks for joining me on this explainer, and I'll catch you next time.